Yeah. So the PPT is visible, I guess. Right. Yes, no, ऑन करके बोल दो.
Yes.
Okay. So yeah, I will go through this PPT first on NLP. So what is NLP? It's just a subfield of AI that focuses on interaction between computers and human language. So natural language processing, basically we are dealing with stuff related to the text or the language which we are having. Processing it can have been a ML part or a non-ML part as well. First, we'll do some pre-processing on the text which we are having, which is data pre-processing, and then feeding that pre-processed data to the ML model to derive the results which we want. So the basic importance, building chatbot, sentiment analysis, machine translation. The what are the techniques which are involved? That also we will discuss. What is stemming, lemmatization, and language modeling. So yeah. What is the use? Text classification. For example, तुमको कोई text दिया हो, you have to classify. For example, whether it is an official document or an informal WhatsApp chat. So you can do it using NLP. Just pre-process, like take the important words of the text which you are having and then feed it to an ML model, which will tell you whether it's a formal text or an informal one, so that you can do the text classification. Entity recognition, yeah, give it text, like give it a description of a cat and a dog. It can classify it binary into whether it's a description of a cat or a dog based on the features of the text which are present in the data. Similarly, machine translation. Machine translation is, for example, Google Translate, on like how Google Translate works. If you are given an English text, you take the important features which are there, important words which are there, for example, in the text, give it to the translator. It translates it, and then a binder is there which binds all of these words into a sentence. So that's how Google Translate works. So these are the regions where NLP is useful. Sentiment analysis example. पॉजिटिव न्यूट्रल नेगेटिव कोई भी टाइप का हो सकता है सेंटेंस so it classifies that on basis of a ML model and based on the features which you need it, right? So the important parts of the process, like data pre-processing, which we'll deal with. First one being stemming, which is stemming limitation, both are quite related to each other. Stemming is reducing the words from their base form to the root form by removing the suffix and prefix. For example, the word university is derived from the word universe, UNIVERS. So it all the derivatives of that word are reduced to this word universe. But sometimes there is misclassification also, like universe, like the word UNIVERSE, that is also classified into the same root word part, which is not what always we want, because university and universe are not quite related with each other. So we go to a more formal part of it, which is lemmatization, which takes into consideration the context as well and the part of the speech before classifying it into or assigning it to a root word. Both of them are inbuilt functions in the analytical library, which we will use.
किस पे
Besides
90
that,
यार हाँ
please turn down your mic
ओके थैंक यू
so that it will go. Next being sentence segmentation and stop word removal. Easy part. Sentence segmentation is, for example, if you are given a text, you have to divide the text into sentences. In English, generally it's easy because we have the periods like a full stop or a exclamation mark, sort of that. So we can divide it into sentences easily. But in other languages, it might not always be possible that it's so easy. Like in Chinese, there is no sort of a full stop or a sort of a thing. So it's only contextual based. So in that cases, sometimes these libraries work, like do lot of have a work. Then the stop word removal. For example, if I say that there is a car standing outside, then there are a lot of redundant words which don't add much of a context to this whole sentence, like is Standing car, standing outside. These are important words, and is this these are not so important words. So we remove all the stop words and then keep only the important words which are there in the context, and then use only those words for the processing part. Then the tokenization part. Tokenization is, for example, if we after we have the important words of this sentence, we take these important words and divide them into separate words. Like we have, if we remove the stop words, we'll have car standing outside as the entire sentence. Tokenizer will just take it, separate it into words, and then there are different tokenizing methods based on which word embeddings are formed. Now, what are embeddings? So, if we have a text or a sentence, we can have embeddings. Embeddings are just word vectors. It's a vector, sort of imagine it as a n cross m matrix or something like that. If we have n sentences, it will be an n cross m matrix where each and every row will represent some of the mathematical representation of that sentence. Sometimes that representation is logical, sometimes it may be not, because it will be based on a pre-trained machine learning model. So there are different types of tokenizers. First example being bag of words. So like let's take it normal, like the tokenizer is this. For example, there are two sentences. This is a sentence and this is another big sentence. We have assigned already that this is the index. This goes to 1, is to 2, sentence to 3, a to 4, and so on. So the tokenizer will have 1, 2, 4, 3 because this is 1 and the corresponding map. Similarly, this is another big sentence, the corresponding map. So one of the type of the tokenizer is bag of words, which we will see. Word2Vec and Glove are other two, but they are ML-based pre-trained models which generate the embeddings on their own. They have been trained on a lot of sentences and have been trained on how to take the context of each and every word into consideration. So they just give the embedding as an output, and you won't be able to understand how this embedding has been formed. But in case of bag of words, it's easy. For example, it's just a map, like how many times this is coming, how many times is this coming, good, and so on. That's a bag of words, like a map of key being the each and every word, and its value being how many times it occurs in the entire text, right? So that is a bag of words, which is easy to interpret, but generally not useful because it's just a frequency based analysis. And generally, as you also might know, that this type of frequency based analysis is not as good as compared to a machine learning analysis because that takes a context as well as different other things also into consideration, right? So besides this, there is another easy to interpret type of a representation which I'll just show you for some bookkeeping purpose. This is TF-IDF. So what it does, it I will give you an example and you will know better. Like if these are two sentences in the entire document or the text which I am having. So this is good and awesome, and this is bad. These are two sentences. We have this, like this is the uh, frequency, like 1 by 5. What is 1 by 5? 5 is the total number of words which are there in the sentence, and 1 is its frequency in that entire sentence. So 5 words, this comes only once. So 1 by 5, similarly for this, all of them, and 1 by 3 here. And we also make another, this is similar to bag of words. We also have this. Now, how does this come? Like this is log. The numerator is how many times a word is there. No, sorry. The numerator is the number of sentences which we are having, right? And the denominator is the number of times a particular word comes in the entire document. So there are two sentences. So 2 is always there in the numerator, whereas in the denominator, this comes twice in both sentences. So in denominator, this comes 2. Is also twice, good is only once, so 2 by 1, and so on. So now what this does is, like this adds some context to it. Like this is there in both of them. So the denominator will be high, and hence this entire quantity will be low. So this is sort of considered that this comes in all the sentences. So it might not be as important as compared to the other sentences, other words. So this gets a lesser preference, whereas good, which comes only once, gets a higher preference. So this is how TF-IDF works. And then these terms are multiplied with each other to get the final embedding output. So this gets zero because it comes in both the sentence, so not important. Good comes only once, so when I find log 2 gets more importance. So this is how TF-IDF works, giving some context to it, but not always useful because there might be other features also, like which word precedes a given current word, which succeeds it. Such things might also add more value to the context, which is generally given by ML models like word2vec or glove. This, as I discussed, word2vec, the most commonly used embedding method which you will see in any of the projects you work in. And glove is also used, but it was later taken over by word2vec because it's just better. And now in recent times, last year only, Facebook has also released its more better tokenizer, fast text, which you can also use. So these are some of the word embedding tokenizers. Yeah, so just a basic conclusion part of in the entire thing. Yeah, so now we will go to the hands-on part. Anybody has any doubts? So we'll clear that first, फिर hands-on करते हैं. No doubts. Theory था तो no doubts, right? I'm taking it as no doubt. Okay. So I will show you the functioning of these parts which I taught. Like not the functioning, how to implement it in NLTK library. There are two libraries you can use, NLTK or Spacey. Generally, I use NLTK. You can use Spacey as well. Both have some or like most of things are overlapping, but some or the other things might be different. Right. So yeah, the screen is visible, right? So I will start with the NLTK part. So I have just imported this library NLTK, downloaded the stop words. Stop words, there is already some preloaded stop words in NLTK library, which you can use directly. Right. So for example, if I write a sentence as, for example, I am Shrey and I am a fourth year undergrad at CSE department, IIT. Right. So, for example, this is these are the text. This is the text you are having. So it contains two sentences. So there are these two functions in the NLTK library: the word tokenize and sent tokenize. As it is suggestive that word tokenize will tokenize it into words and send tokenize will of course tokenize it into sentences. So send tokenize of sent sentence will just give you just so punct I have not downloaded, so maybe starting with word token. Yes, I have to download. Yeah, so it tokenized it into two sentences. I am Shrey and this the second part. Similarly, word tokenize will work. spelling. So it tokenized it into the different words. I am Shrey, full stop, and this other things. So I have already imported the stop words from NLTK corpus. So what we can do is that, for example, if we take all the stop words and then we can remove this stop words from the two sentences which we are having. So for example, what we can do is I can set the stop words. This will what write first and then
आपके से जाने से थे मतलब से
sorry.
मेरे से बॉट एप खोलो हेडफोन पे कनेक्टेड है इनको स्क्रीन दिखाना है क्या मेरे को स्पीकर चाहिए तो मेरा स्पीकर अच्छा मेरा क्योंकि
So yeah, I have stored all the stop words in this stop words part. This will set all the stop words of the English language into the stop words list, and then I can form a filtered list of, for example, list one. I will form this list which will only contain those words which are not stop words and are really important. So, for example, what we can do is that for word in I did not. So I will iterate through all the words in this token. If it is a part of this top words list, then I will not take them, else I will add them to list one. That's what I'm going to do. So if words dot word. So yes. So yes. Now you can see that all the stop words like I and M are stop words, so they are removed. Shri is there. Full stop is there. I am are another stop word, so they are removed. Fourth year undergrad at is removed. CSC department IIT Kanpur. So these are the words which are generally important. So they are all which are remaining in the filtered list which I am having. So now we can do some operations with this filtered list and then create an embeddings from it, or like pre-process it in different ways to give it to the model based on the purpose which we have. Right. So yeah. Now maybe we can do stemming or lemmatization on it, and then yes, that will all be mostly the part of pre-processing. NLTK import Potter stemmer. So this is one of the stemming library or sort of a function which might be there, which you can use maybe for stemming. So we set the stemmer to Potter stemmer and then use it directly for stemming the entire sentence which you might be having. So if finally list 2 will contain all the stemmed words like the base root words of the words which are present in list 1. So what we can do is stemmer dot stem of word for word in list. So see, list 2 is having, yeah, we did not have any sort of a good word which might be reduced. For example, I will just give an example how generally it is reduced. Like it is lowercase always, the stemmed words. Besides that, I'll show you an example of, yeah. So discovery, the base word is discovery. This changed Y to I. So this is one of the examples of how the normal English words are reduced to the root words. So all the sentences, all the words which you might be having in the word tokenized list, it might be reduced to its base form, and then only the base form can be given to the model. The use of this being that if the different tense or the different sort of representations of the same word, like university, universities, these two are different words, but the root word is the same. So this bag of words or TF-IDF, they all count it as different if we don't stematize it. So the main reason of stemming is that the only the root words are taken into consideration. So complete context, like proper idea of context can be taken. Similarly, lemmatization can also be done. It's also a part of the analytical library, which you all can see. Besides that, what function? Mm, yeah, uh, POS I will teach maybe in the next part, or let me show you now. For example, if I write that NLTK dot, there is another function here, POS tag. It will assign every word with a part of speech which it is a part of. Sometimes it may be useful that you take this also into consideration. For example, list two. I have to download it. Sorry. Why is it not? Function is this only. Maybe some connectivity issue, or maybe I have not downloaded some package from the NLTK library, which is the reason why it is not working. Otherwise, it assigns generally the part of speech to each and every word which is there. For example, Shrey, you can see here is a noun. Yeah, maybe, for example, if I say it's a beautiful car, so beautiful will be adjective. So it will assign each and every word which is there in the list which we provided to the corresponding part of speech, which can also be further used. So yeah, maybe this is the reason. Yes, yeah. So I had not downloaded this package, which was the reason why it was not working. So yes, so you can see like I fed this token list to it. So there is like this is a pronoun, and similarly this is a noun. There is a specific word in wording like what NLTK uses. For example, NN is used for nouns, PRP for pronouns, VB for verbs, then JJ for adjectives. Yes, there is a fourth. So that's an adjective. Similarly, you might use this as well. What else? Yeah, lemmatization. I can use this as well. From so like water stem was there. There is this WordNet lemmatizer, which is there in the NLTK library, which will help you lemmatize it. For example, if I assign it, this will be my lemmatizer, which I'll be using. So maybe I'll show you again this discovery. Again, I have not. Yeah. So it lemmatized it, like it will not convert it into its root word, but it will assign all the different words with the same context or same part of speech into one. For example, if I'm having discoveries, yes. So generally it uh, combines all the words of the different like this plural form or another person like told the same thing in different person, so that all type of the words are combined into the same category, and hence lemmatization works that way. So all the different context comes again into the same part. So yes, that was I guess all. Lemmatizer, stemmer, tokenizer, stop words. Sentence tokenizer. Besides that, one part is left. TF-IDF also is one of the tokenizer which you may use. I have not shown you here that. Maybe you can try using Word2Vec as well. I have just given a basic of NLTK only. You can use other like tokenizers, try it on your own, how you can use Word2Vec, FastText or Glove. If you face any difficulty, then let us know. Yeah. So that will be all, I guess, from the tutorial part. Do you have any doubts? Any doubts? No doubts? फिर कुछ हो तो बता दो यार. NLTK library is clear. I will share two resources with you. One on NLTK and one on Spacey as well. And one will be a generic one from where I took the resources for this NLP presentation. So that all I will share with you. But yes, so you can go through them. Yes, NNP are nouns. I will share that doc. Like there is this tutorial on NLTK. It has a complete list of how this naming is done. NNP to nouns, PRB to pronouns. There's a typical naming. So yes, I will share that with you. The three links: Spacey, NLTK, and NLP basics. Besides that, next week we will be going like how these word embeddings or the tokenizers, output of the tokenizers will be fed to neural network models like RNNs, or going complex also sequence to sequence modeling or BERT models as well. Complex models have come nowadays, but generally the best model over the periods of time has been BERT, which we may or may not study based on time constraints. So we'll look into that. Yes. Maybe in the next 1 minute, you can all write your roll numbers in the chat so that I can take the attendance, and then maybe we can leave. Till then, if anybody has any doubts, we may clear it. Assignment 2 is released and it's not graded, but it's for your practice. Maybe I will give you a short assignment on NLTK as well. NLP, basically, you can use NLTK as well as Spacey. And it will also be for your practice only, I guess. Next week, we can have a big assignment, maybe. Okay, so I will end the meeting if nobody has any doubts. So last 10 seconds for the attendance, not more. Okay, done. Okay, meet you on next.